I hope you enjoyed this exciting panel we have here. And to introduce our exciting panel, it's my pleasure to introduce my friend, colleague, Ray D'Adazio, the president of Thornton Tomesseti.
Good afternoon, everybody, and thanks so much for being here at the CUNY Graduate Center. And thanks to everyone who's joining us on the live stream as well. We have about 90 minutes on a topic that really could last a lifetime, so I won't delay and I'll get right into it. Our topic is vitality, right? Those of you from Thornton Tomesseti have been hearing a lot about vitality over the last year and a half. But on the right-hand side of this picture, you can see the Fortune magazine cover that contained the article that really started it all for us. It introduced us to the idea of vitality and looked at why companies decay and fail and what you can do about preserving and cultivating your own vitality. So what followed for us was an engagement with the Boston Consulting Group, who had co-authored this piece about the Future 50. It was a kind of a no-brainer, since there's so much data showing that the AEC industry, to put it politely, lags most industries in its pace of innovation. So our discussion here today will look at three ideas that underlie the idea of vitality. Okay, here's our working definition of vitality, and what we call the bullseye diagram are the 11 metrics that quantify our vitality. So vitality, I'm not going to read the slides, but it's the capacity for a company to grow and explore new opportunities and renew strategies to grow sustainably. And we like to have metrics around that concept of vitality, and in the bullseye chart you can see the 11 metrics that we use to quantify Thornton Tomesseti's vitality. A related concept is that of ambidexterity. And this is a really, really hard thing for many companies to do, right? The concept of, there are two circles there. The first circle is about current results, how profitable is the company right now. And the second, of course, is the vitality, the ability to make relevant bets on the future. And we have to do both successfully. I have here a quote from Hemingway in The Sun Also Rises, and it's there's two people talking, and one of them says, "So how'd you go bankrupt?" And he says, "Gradually, two ways, gradually, then suddenly." And being ambidextrous prevents that from happening. And the funny thing is, if you really think about some classic corporate cases, Kodak was a company that was having its most profitable year before it declared bankruptcy. And they were the guys who invented digital film. So it's really an important concept to try to be able to be ambidextrous. The third and final concept is called freshness. How many new bets do you make? How much revenue can you attribute to those bets? Kodak, in fact, invented digital photography, as I mentioned, but they were concerned about it cannibalizing the film business. And we all know how that turned out. So these three ideas, vitality, ambidexterity, and freshness, will come up or underlie the discussion we'll have this afternoon. The details of our panelists are in the program on your seat, so we're not going to spend time reading out long, impressive bios. These are very impressive people, so take some time to read the bios. And in the last 15 minutes, we're going to open it up to Q&A with the audience. And please wait for the wireless mic to get to you so that, again, we're live streaming this so that the live stream will be able to hear your question as well. So please let me welcome the panelists to the stage. Let me start with our moderator, Tom Scarangello, Mary Boyce of Columbia University, John Gilbert of Rudin Management Company, Jit-Ki Chin of Suffolk Construction, and Chris Sharples of Shop Architects.
So are we all turned on?
Think so.
Okay,
All set.
we're good. All right, well, thank you, Ray. I'm just gonna dive right into it because, as you might imagine, we've met and talked before. Actually, just as real quick, just last Friday, was it Friday, Key, that I saw you in Chicago, Thursday or
Right.
Friday, speaking at a Built Worlds conference about these very topics, about where our industry is going. So let me start there. Let me just see if this works. Yep. I'm going to throw an image up on the screen. This is one of the things that inspired us back in 2014, the Harvard Business ranking of industries and adopting innovation, with construction being dead last. Jackie, you've been about 18 months in this industry, right? You came out of McKinsey.
That's right.
One of the things that we've talked about is, what was it like coming into this industry? And what was it like being, as a chief data officer, bringing in something different and trying to change from within an industry that has this kind of reputation?
Yeah, so it's been a steep learning curve for sure. It's a fantastic industry, but there's a lot of deep expertise and knowledge within the industry that I had to sort of come up to speed on. At the same time, I had the perspectives of seeing a lot of other industries from my time at McKinsey. And so in certain areas, and I came in as the chief data officer, so take data, for example. In certain areas, I know we could do better, I knew that on data, some of the modern techniques and technologies that are now available to us could allow us not just to look backwards, but look forwards, for example, not to automate a whole lot of the manual processes that we have. And, who knows, eventually help us build differently, build better, faster, better, cheaper, as they say. It's been a remarkable journey. I think, there are obviously a lot of challenges with all companies to innovate. But in construction particularly, there are some challenges that are specific to us. Jobs are quite long, the types of jobs that we do now, multi-year jobs. But technology and innovation is moving much faster. And so how do you inject that innovative spirit into jobs that are kind of mid-flow and have already a set path of doing things? I think ours is an industry with a lot of risk, right? And when you're kind of and our job as general contractors is also to manage that risk. How do you balance the agility that is required to innovate, which requires a certain appetite to do things differently, versus this, very risk conscious approach that we have as builders? That was another big challenge. I think the largest challenge, though, that we face is a challenge of talent. So to innovate and to do a lot of the data and tech that we've done, we needed to bring in new talent. New talent thinks very differently. You imagine your average Google software engineer, right, to do a lot of the tech stuff. How do you bridge that communications gap between that new talent and the existing business? How do you learn to have them communicate with each other in a mutually productive way so that we can bring that diversity of thought together and find a better way of doing things? I think that also has been a big challenge for us.
So let me throw it out to all of you. I mean, you all, whether it's at Columbia or at your firm, John, at Rudin, or at Shop, you've all had success in changing and starting to become more innovative and change the industry and change academia. What are some of the barriers that you hit as you were going down that path, and what are some of the lessons learned for people who are trying to do that or trying to get on board? I'll throw it out to anyone to.
I think one of the things is we operate in a very litigious environment, and that really, the fact that as an architect, I'm not even supposed to get involved in means and methods. So, the team that's actually helping to design the building, working with the engineers, can actually have an informed, constructive conversation and talk about, well, how do we realize this? We've been compartmentalized. And so, obviously, technology now is allowing us to sort of erode those barriers. Obviously, we got to catch up with some of the legal matters and things like that. But there is this, we're starting to see these cracks where there's definitely a potential for a lot more collaboration across the field, which is incredibly important if we are going to innovate. So that's something that, and we'll probably get into this, you know, as we talk more this afternoon, but for us, visualization is at the core of that. You know, right now, I do believe, you know, we are still very much in this Tower of Babel situation, and how do we use visualization as a way to sort of, you know, communicate in very, very intimate ways and manage complexity in a very, you know, very, again, hands-on, in a way, very human way. We tend to silo everything right now. Throw it over the fence. It's not my problem, it's your problem.
Yeah, it's also that risk-averse
Yes,
sort
exactly.
of approach. Yeah.
So I think you really have to define the problems you're trying to solve. I think the days of, you know, focusing on technology just because it's cool, over, done. Been there, done that. It's really, for us, it was about, we saw the need for a new tool. And it really came about in 2009 when Con Edison reached out to us. They had received a chunk of money from the federal government as part of a stimulus package. And it was all about, let's make the grid smarter. And let's prevent from what happened on that fateful August day of 2003 when 55 million people lost power across the Northeast and Southern Canada from ever happening again. And they picked us. They said, hey, Rudin, you want to be the commercial office petri dish for the smart grid demonstration project? We said, yeah, sure, we might learn something. And so we walked into the meeting, and they had up on the screen 2 graphs, one showing what was going on with the grid from a voltage standpoint and from a frequency standpoint. And they posed a very, very interesting question, which was, we, Con Ed, had a 45-second early warning that something bad was going to happen, and we want to be able to give you, Rudin, and your friendly and unfriendly competitors at least 30 seconds of that early warning. Do you want it? We're like, yeah, we could program our elevators. They feel that dip in frequency in the grid. They go to the nearest floor. They let people out. People may be inconvenienced because they're on the wrong floor, but they're not stuck in that elevator. And conversation ensued. We walked out after the meeting, and I said to Gene Bonnieberger, who's my senior vice president for operations, I said, Gene, how the heck are we going to do that in 30 seconds? And he says, I have no idea. And we literally walked around the corner on 14th Street, sat in a pizzeria, started, playing mental ping pong. I put my early, version of an iPhone on the table, and I looked at it and I said, this thing's got an operating system. Why don't our buildings have an operating system? If we had a true OS, I could take external data, throw it into the mosh pit of our internal data, and make it actionable within that 30-second period. So we began to really focus on that being the problem that we were trying to solve. We said to ourselves immediately, duh, right? What a simple, common sense solution to a problem. All buildings should have an operating system. Somebody else must have thought of this somewhere around the world. We literally went figuratively and literally around the world looking for it, couldn't find it, and we said, you know what, we have to build this ourselves.
So we're going to talk a little bit more about Nantum in a couple of minutes, but let me ask you this. What was it, you said, well, they came to us. I think you're being a little humble there. Why Rudin? What was it in your culture? What was it in your business that actually made it work? Because I'm sure a lot of other people, they'd be saying, no, I don't know what I'd do with that, or I might know, but what's the chances of me getting my partners and the rest of the organization to buy into this, trying to do something new? What do you think it was that you brought to the table?
Well, we had been doing smart building technology since 1995-96, literally right after when Al Gore was kind enough to create the internet for us. We had a vacant building at 55 Broad Street. It had been vacant for 6 years. Drexel Burnham Lambert was in there, and when then U.S. Attorney Rudy Giuliani caught Mr. Milken with his fingers in the cookie jar, that company went bust. We literally sat vacant for 6 years. Smartest thing that the family did was to gut the building, do all the remediation of asbestos, and they were ready to go. And we were the first ones when we read Nicholas Negroponte's book, Being Digital, about, smart, ready real estate. And we're like, smart, ready real estate, what the heck does that mean? And that evolved into us being the first property owners to literally deliver optical fiber to the desktop and to use carrier-neutral risers within our verticals so that carriers could plug in easily, tenants could get multiple choice of carriers, and we could sleep at night knowing that we wouldn't have spaghetti in our vertical risers. So we had been, and then we never looked back after that. So we had been constantly pushing the envelope. What is this technology? How do we use it? What's good? What's bad? We fell down, we picked ourselves back up. We fell down again, picked ourselves back up, and then got into the software world.
So I would say if you look at a university environment, this is kind of how we operate. And we even have a word for it. We say a convergence of different disciplines all working towards a new problems in the world. So if you listen to everything that was just said here, where you see innovation happen is at the interfaces of different disciplines, and you need to have a mindset where people who are working on very different things are willing to come together to attack a problem. And this is what everyone here has actually just said is happening in industry now. And we try to create our research labs around this kind of enabling those opportunities for this cross-disciplinary thinking. Because that is where something new will happen. That's where a breakthrough will happen. So, Jitki coming in with her data science background is giving a fresh new look in the AEC industry. And it's again because the data science is now bringing something totally new into an old system that can really rejuvenate things. Smart technologies coming into buildings and enabling a building to be looked at with an operating system. So you need to have that open mindset to welcome and think of how do we incorporate these new ideas.
What's interesting is we've been using this meme of the island of Murano, because we had a speaker about 3 or 4 years ago, Stephen Johnson, who talked about what he calls the adjacent possible, which is exactly what you described, where people coming in with different capabilities and strengths and creating something that they couldn't create individually. He uses Murano as an example because they put all the glass makers on Murano so they wouldn't burn down Venice, and glass technology took off because of the interaction between people who were trying to solve the same problem but in different ways.
It's also because they had really good sand out there.
That didn't hurt either. So let me jump to the next question, and I'm going to throw it to you, Chris. At our meeting, you'll see we actually have a slide with a quote coming out of your mouth. It was earlier in the day, because you talked about once about it. I used it in a different way. You've talked about it's really about the process. Innovation's about process. Mm-hmm. And the slide that we've shown here is something that is probably one of the most embarrassing things for our industry if you look at what's gone on for productivity in every other industry except for our industry. And whenever you go to these kinds of gatherings with people who are trying to change this, we all see the same slide. And it really resonated with us, your thought about a process, because in the history of Thornton, Tomesseti, and other firms, there's been a lot of, as I say, we've had 3,000 PSI concrete to 20. We've got steel has increased, all kinds of things, all kinds of tools have changed, computers, everything. But it didn't change any of this. But what's happening now is the process. And so can you tell us about why you see that and why you believe that's the driver of the innovation that's going on today?
Well, we see a lot of product innovation, in our field. I mean, material science innovation,
Right.
Just glass alone right there. But, we are in a very socially oriented field. I mean, we're dealing with a diverse group of skill sets. We've got the owners, we've got the designers and engineers, and then you've got the people who realize the project, right down to your labor force. And the fact is, we do all speak different languages. I mean, it's funny, when I go to a dinner party or something, they go, "Oh, you're an architect, so what kind of architect do you do?" And I said, "Well, we do everything except for single-family homes." The fact is, in the old days, before World War II, architects did everything. Now, you specialize, you compartmentalize, because that's how you manage risk. So when we got out of school, and I didn't come to architecture directly from high school. I liberal arts education, political science, fine arts, history. And when I got out of Columbia, I still did not see how a 2D drawing was the best way to communicate and manage information. And so, you know, maybe being dyslexic helped me and my brothers sort of just to question that whole side of things. But two things happened in 95 and 96. One, there was a show at the National Gallery of Renaissance models. And when Renaissance models aren't something you put on a table and you actually can walk inside. There was Michelangelo's dome of St. Peter was 25 feet in diameter. And you could walk in and you could imagine how you would start to think about how that thing would go together. There's a great quote by Alberti. He says, it's important you build these models so you understand how to, you know, construct them. But at the end of the quote, and I'm sort of paraphrasing, but it's also good for cost estimation too. So it's not only like, hey, this is great. And then the following year, Nova came out with the program, Boeing's 777 story. It was a 4-part series. You can Google it on YouTube and watch it. But what was great is everything was done using a digital platform. So from design to sharing that design with your engineering team, to sharing it with the people who would actually do maintenance on the aircraft, to your customer. And so this virtual prototype was really what was the shared platform for all these different entities, and everybody could understand. They could understand how they would go about making decisions in real time. There's this great story where they had all the mechanics in the room from all over the world, and one of them, the guy from Anchorage, says that access door is not going to work for me. And they're like, well, what do you mean? It's large enough. No, I'm going to have a big glove on my hand, and I'm not going to be able to reach in there. So everybody's giving real-time feedback, and that's affecting the model. And at the end of the day, for us, it is the digital model that is the key. Now, the problem that we saw over this 25-year period of when we started the practice was it was great to help us in the design process, but then we hand the model over to the build team and the model usually gets thrown away. Now there's certain things that, you know, at TT, you know, at Tekla, some of these models play a big role when you move into construction, but in most cases it still remains as a representational device. So we started to go outside of our world and look at the aerospace industry, manufacturing industry, where, you know, you don't have rework. You work with models that are, you're designing for manufacturing. You're taking information and it's going directly to the manufacturing floor. There's no shop drawings. So we started looking at other platforms outside of our practice, you know, Dassault Systems, CATIA. And how we've been, and we realized we're not going to be able to go to the building industry and go, oh, let's do the whole building in CATIA. But what we focused on was certain components in the building process, specifically envelopes, and how we could begin to talk directly to to fabricators using this platform. And on our first big project with TT was Barclays, where, you know, we had, you know, over 12,000 unique panels on 940 mega panels. They were all different. We managed that whole process using that software. But to bring it home, what was key was it was a platform that we could share across different skill sets. And there was a human connection there with that. And that, to me, is probably the most important, if you have people in the room working the problem together and it's very transparent, that's the best way to manage risk. And so, you know, for us, that process, you know, how do we take that process and now apply it to the whole building? That is obviously the challenge, because trying to get all that stuff to one job site in a city with all the congestion, all the particulates, all the noise, is not the smartest way in the 21st century to build a building.
Well, you know, and what's really interesting about what you said is it was architects like Shop that actually drove us to create Construe, the program that now we've spun out and other people are using, because back in the early 2000s when we were just starting to get into this virtual modeling world, and whether it was Revit or something else, we wanted to use it. As a matter of fact, there were architects who were saying, well, we're going to be completely in building information models in 5 years, so if you're not in there, you're not going to work with us. It was funny because a lot of them actually, we ended up being ahead of them, mainly because what we have to convert is much easier than, you have to decide where to stop modeling as an architect, right? Do you stop at the doorknob or you keep going, right? We have limited materials. So we went out and internally created a program just for internal use that could make all these talk to each other so that we could control what we're delivering and then give you or give the owner or give the fabricator whatever they wanted to get in that form. But that required, again, it's a team sport in our industry. So I throw it back to this issue about process. John, you're one of the few where the process, you could control the process to a certain degree, right? Because you could decide for your building stock that you could do this. But you're out there now also talking to others, and I want to pull up some of the examples of what Nantum can do. How have you gone around to tell people to change the process, right? Because you convinced yourself. Now you have to convince others to get along for that product to be successful. How does that work? And I can pull up a couple of slides here if you want to give people a little bit more familiarity about how this works.
So Nantum, a lot of people say, what's a Nantum? Nantum is actually derived from an ancient Algonquin word that means prayer or blessing. And we named it that because we really saw this as a blessing because it answered a lot of our prayers in terms of having a tool where we could have situational awareness in real time, where we could blow up all the silos that Chris mentioned earlier, blow those silos up and allow data sets that never talk to each other to correlate amongst each other. It gives us the ability to use machine learning so that the data that we looked at today and collected today can help us tomorrow run the building better. And it can also prescribe what we should be doing ultimately as we begin to understand not only the physics and chemistry that constructed these buildings, but now to a greater extent the sociology and the biology that we need to understand in terms of the human rhythms that are happening within our buildings. So what you're looking at right now is literally, it's a screenshot. I apologize for not having real-time data, but on the aggregate, on my phone right now, when I sat down over here when we first came in, there were about 22,000 people in our 15 million square feet of space. We're now down to 19,273. And that's, people are leaving. Obviously, it's a beautiful day out. And so those 4 o'clock meetings might be ending a little bit earlier than normal. We're at 22 megawatts of power, 62 M-pounds of steam, and we've already consumed almost 300,000 gallons of water. Now, why does any of that matter? It matters, and if you go, and here's the aggregate slide. So this is for me, I can now understand exactly what's going on in our portfolio because of the repetitiveness that I see this. I know whether it's a good day or a bad day, whether something's screwed up or not. If you go to the next one, Tom. We then break it down into individual buildings. So this, I think, is 345 Park. I can see that's 5.2 megawatts, 27 M-pounds of steam. I have real-time temperature data. Not only has this saved us $5.5 million a year because of the real-time nature of it, because we're able to ultimately compute that thermal inertia in a way so that we can, fancy way of saying, I know I'm talking to a lot of engineers, so you know this, but how quickly does that building cool down or heat up? We've shortened our operational day. Maybe the next slide is maybe one. Yeah, so this is I think, tells the story of everything. The orange curve that you're looking at is actually an actual electric demand curve from 2005 on a similar day. The green curve is a curve from yesterday. And what you're looking at is, so you can see how we've redrawn that consumption, where back in the day we would start our engines maybe at 3 o'clock in the morning. Now we're starting them at 6:50 because we know it only takes us 10 minutes to get temperatures into zone so that level of comfort that the people who are paying us money for rent deserve. And then ultimately you can see that divot in the middle of the day. That is taking two data sets that never talk to each other, occupancy data and fan speed. And that's the resulting savings of electricity simply by occupancy sensors talking to a gateway, and that gateway telling the BMS, hey, the occupancy sensor saying people leaving the building, slow down fans, this is the resulting energy savings, and ultimately, when you come back from lunch, you're not freezing in your office like many of us have experienced because we're not pushing the same amount of volumetric air that we were before people went to lunch. So what we're able to see here, and then at the end of the day, you can ultimately see from a ramp down standpoint, we can shut our engines off much earlier than we did in the past because we can then ride that thermal inertia for the rest of the day right before people leave. So we've cut our hot and cold calls by 70 to 80%. So quality is up, cost is down by 55 cents a foot, and people are happier. The ability then to take this, we've taken it outside, we've showed it to a lot of our friends, JP Morgan Chase, a lot of other, I don't want to make this a commercial, but largest bank in the world, largest asset manager in the world, largest REIT in the world are all of our customers now because they see the value. And everybody says, oh, data is the new oil. Sort of, but you got to refine that data, just like you've got to refine the oil. It's not just about the data. It's about what problems you're trying to solve with that data analysis and those new data correlations, and ultimately whether people care about the solution to those problems or not.
So you brought out a product that one, you could see in your own ecosystem that it was large enough that the financial value to that, right? And you're also talking to a group of people who are right there at the bottom line. One of the challenges we face is so I'll use our program Construe, right? We see how it works, but we had to change our process internally in order to get the benefits out of that. Getting others in the industry to use it are very difficult because until they see the change and the bottom line change, which takes a little bit more of a leap. You were able to just say, here's my energy bill, and it went down. I'm sure others here are running into that same problem. If you've got a transformational product or process, how do you convince others in our industry to do that? Because if we're doing it alone, as we know, we're not going to get there. We have to collaborate, and as we were talking earlier, before we stepped up here, all you need is one person on a team to say, no, let's not do that innovative thing, and on our projects it doesn't happen. So what has been your successful way for others to kind of take some of this technology and where it changes the process and convince people to change the way they work, not just to use a new tool?
I'll start. It's a great question. So we went on our own journey to embrace the digital model and actually flow that into the construction in a way, as you say, some of our counterparts may not. And it was a struggle because it required people to do things differently, and you constantly face the question of, I've done this way for 30 years, why do I need to do anything differently? I think in our situation, we had the benefit of having a very strong visionary leader who were able to say, this is the future, we have to get with the program, let's do it. You couple that with a strong field force on training, like the importance of actually getting out there, training and teaching all these new capabilities. There's just no shortcuts to it. So, end-to-end kind of standardizing the way we do it, making sure that all the materials, the training materials, the SOPs, the write-ups were good, and then just measuring the utilization and measuring the value capture, because I completely agree with John here. It's about the problem. And when you come in, it's all about understanding what problem you're trying to solve, and then just using all the new techniques to solve it. So we measure value, and sometimes that value is a long time in coming. Sometimes it's a multi-year before the project finishes. Sometimes it's case-based because the project's all different. But you have to have that discipline of going through with it. And then one day, a few years down the road, you'll be able to say, this is the value that I've captured from this innovation.
I think his question, though, more is on how do you do that faster? And I think Chris was identifying you don't want to reinvent the wheel, right? So the automotive industry, the aircraft industry have amazing tools. that evolve very quickly. Simulations now, complex finite element simulations can now be put in the hands of an early stage designer because of rapid advances in how much time it actually takes to do a simulation. It can be done at a very early stage design. You can do bio-inspired design using optimization algorithms. All of that is now done very quickly. It can be put in the hands of a designer. That is why it should be entering the AEC industry much sooner in the design process. You've talked about everything that John was just talking about is enabled because of the cloud, right? That we can share all of this information across these different platforms. Other industries are already doing this, right? So the sense of how can you also be adopting? You don't have to reinvent everything. How do you adopt what's out there and that is now at a stage where it can be adopted and brought into other industries?
No, I completely agree. We talk about the building information model. That was really not for us. That was an innovation. We just adopted in previous technology. You talked about Boeing and all of that there. But one of the challenges we find is even when there is technology and the ability to use it, we may not be the market. So we actually spun out a company called OnScale just a while ago that is actually cloud-based computing that has been reformulated to focus on markets that are 5G and MEMS because that's where the money and that's where the high computing power is. We're trying to get them to do things like soil structure interaction and CFD because cloud-based, again, there's limitless computing power, and if you're in the cloud, it's also no startup. You can run it on your iPad.
Exactly.
But our industry, and we're getting there, is one in which we're not thought of as the market. Right? I think the market is starting to look at us now, but it's not at the market. So,
but that's where your advantage is.
Right.
You know what your market is, so how can you better identify things to bring into it?
So let's jump, because I want to talk about collaboration.
I wanted to say another thing. I think sometimes what makes something really happen, and John's first example was great at that, is a crisis, right? So a crisis spurs innovation. Well, and so you had your crisis of how do we get
Vacant building for 6 years.
Right. Well,
That's a crisis.
how do we how do we not have a power outage
Right.
and how do we prepare for that?
So thanks for queuing up the next question, though. So how many people in here take the L train? Mary? So you can give Mary and her team a standing ovation. But the thing that I found ironic about that, we have this discussion about all the time about insiders and outsiders in our industry. Who's going to drive the innovation, right? So, and the story that I heard, and I'm sure you can hopefully tell us the more detailed story, was that this wouldn't have happened except there was a Christmas break that allowed the academics to actually have enough time to think about a problem that had been studied for years and was ready to go off with the L train, the shutting down the tunnel. But it seemed like this is one of our problems in our industry where we look at academia as the outside. When did that happen where you talked about the master builder? There was a master builder, but everybody was kind of in the mix. And when did it become that suddenly academia weighing in on an issue like this as thorny a problem as replacing doing the work on the L train became something as an oddity? And so can you tell us a little bit about how this happened and what are we doing so this can happen more often?
Right. So I'll try to be really brief, so I don't just hog the stage here. But so the L train tunnel is also called the Canary Tunnel, and this is a crisis that the Superstorm Sandy really damaged the infrastructure that housed the cables, the cement bench walls that house the cables. This is collapsing in, and of course the cables are also corroding because they've been sitting in salt water. And there's been periodic repairs just to try to keep it going, but it was really needed an overhaul of the system. So the approach was let's rebuild exactly what's there because we know that works. That's in essence, and we have to recognize safety is a big So the tunnel was going to have to shut down for 15 to 18 months. Full shutdown, 270,000 people travel this tunnel every day. They're going to spill over into other transportation systems across New York, affecting hundreds of thousands of other lives. So Governor Cuomo wanted to take a fresh look. That's what he called it. Take a fresh look. Come have academics come who are not vested in any way in the situation, come and take a look and see, is this the way to do it, or is there something else that can be done? This did happen right before the Christmas break, and so we did have to spend hundreds of hours collectively. This is other faculty. I'm a mechanical engineer, so we had civil engineers, electrical engineers from Columbia and Cornell work together. The MTA was put at our disposal, a consulting company was put at our disposal, and it was highly collaborative. But it was indeed a very different look at what was going on in that tunnel and looking at the functions of the system as opposed to rebuilding what was there. What functions were needed? How do we bring new technologies, but proven technologies, into that system? And that's what we've done. You know, we had press criticism. I'll tell you a favorite question is why could your team, who were not tunnel experts, why did you think you could go in and look at this and do something different? And I said, well, I think it's actually because we were not the experts who just work on that every day. That you could look at something different, look at it in terms of its function and what we needed to do and what other technologies were out there that were not being used that could propose a very different solution. It actually is a simpler solution. It's not requiring a shutdown. It actually also is, I think, a far superior solution because it also enables very easy long-term maintenance. So this, but this idea of a crisis can spur innovation and can make you have a very different look at something. And I think your example earlier was very much like that, that you said, what are we going to do for these buildings so that, you know, we don't have this massive power outage and people trapped, et cetera. So there can be this sense of there are things out there that can really be making a difference, technological solutions that maybe are being used elsewhere and aren't being used in this capacity. So I think the bigger question is how do you make that happen regularly, right?
You know, that was going to be my follow-up, because the issue is we've talked about things like, you know, back in the late 2000s at the recession, or a crisis is a terrible thing to waste, right? So yes, sometimes innovation comes out of crises, but that, you know, that's a bad thing to rely on to drive an industry from where it is to where we want it to be. Yes. How do we create a model where it happens more often? One of the things we talk about are the principles that allow us to collaborate, the kind of trusted partner principle. And I always point back to the original IPD principles. Forget the whole IPD process, because they list things like early involvement of all parties, use of latest technology. And it seems like we always knew what to do. We know what to do in order to happen, but we rarely do it. We rarely say, hey, a project's going to start. You know, a lot of times clients will ask us, when should we get involved? I'm like, as early as possible. Because just to hear what the problems are and who else should be in that conversation. So how do we as an industry, how do we make that happen? How do we get people, even if it's not my job, but I happen to be interested in helping the process, how do I get involved? How do we get academia involved? How do we get people so you start the problem with all of that thought rather than in a reactive way or just missing it completely, which is what happens more often.
So can I say, I think there's two things. So one of the things that Governor Cuomo, the MTA, and others are doing is they're making this outside look be a regular part of any major infrastructure project in New York. But I think another one is what's happening with JITKI is that you need to bring in those new different perspectives directly into the company as well. And I think especially bringing in someone who's been in a different industry with those tools to now come in and take you're basically giving a fresh look in your industry.
Yeah,
But I'll let you talk about that.
I was just going to build on it because, you know, there are obviously many ways to stimulate innovation. I completely agree with the problem back approach. Like, if you have a crisis, that makes it easier because then people have to change. I think another approach, and one that happened to us, is that just put people with different perspectives together. And if there's enough trust and enough kind of commitment to solving the common problems, new approaches can emerge organically. And so I want to tell the story of how we came about to do the predictive safety proof of concept. So just a bit of background is like, you know, the problem's not different. Like the main problem you got to solve in safety is how do you prevent an incident, right? You don't really want to just report an incident is happening. You actually want to look ahead and actually prevent it if you can. You know, historically, the safety management systems is that you have observations, you know, you sort of record near misses and so on and so forth, and you put in place the practices that you believe will manage that. And that has taken us very far as an industry. When we came in, I came in and one of the first people I hired was a data scientist, right? Sort of a practicing one. My practicing days are a little bit behind me. He, you know, so we looked at all the data and we're like, well, the problem is people record observations differently. You know, you change your criteria, everybody takes a different observation. Some people check the box, right? Like, it's not very interesting information and there's not a whole lot of value in it. But you know what? Like, we've been taking pictures on a job for a long time now. Images, the quantity of image data has been exponentially increasing. And it's only going to keep increasing, right, as it gets easier and easier to take videos and images. So it's like, and nowadays we have image recognition techniques. What if we used image recognition to identify safety hazards like PP&E adherence, like, you know, working from height, like housekeeping, because that's a sign of how well run the job is. And now if we use this time series of image information, all of which are tagged with metadata on when it was taken, combine it with things that we know matter, like weather, for example, matters for safety, what kind of job it is, what subs are on, you know, what work's going on at that point in time, are we delayed as a schedule? You put it all together with the modern analysis techniques now, just run it and say, can you predict when something's going to happen, when a safety incident is going to happen next week, right? Just at that level. And, you know, the safety information is relatively clean, right? We report the incidents to OSHA, so you have that history of information that historically we just do that. Why don't we just predict? So we ran that proof of concept with a partner, startup partner of ours that had the image rec capability. We provided the 10 years worth of data. They ran the analysis for us. And then the research says that, well, it does, right? With 80% accuracy, I mean, you can tune kind of how accurate you want it. You can predict. Now you start putting a value to it. What's the average cost of an incident? The insurance companies will tell you, right? It's in the tens of thousands. Now you say, okay, well, even if I couldn't prevent all the incidents that are predicted from happening, what if I only prevented a quarter of it, either via some safety stand-downs or, you know, the industry needs to figure out that faced with a probabilistic prediction, right, as opposed to a deterministic one where you can pin the blame on someone else or on a specific person, what do you do? And so that process innovation has yet to happen, but we've now convened a group to talk about it. How would you operationalize it if you had this forward-looking risk meter? And then you just do the math. You're like, well, if I prevented 10 incidents a year, what's that savings? If I prevented 20, what's that savings? And to the point of real-time information, now if you go to an insurance company and you say, well, what if I tell you that I am monitoring this in real time and I have all these, you know, practices that I'm going to put in place should my risk rating go too high? How will that change how will that change insurance? So really interesting questions that come out of it. And the genesis of that was no more than a bunch of people with a different mentality and a different way of looking at things. All, you know, safety, the problem definition of safety is a pretty straightforward one, right? Let's just prevent incidents. And then saying, hey, can we think of new ways to prevent this?
But I think what was most fascinating about that is that how many times did she use the word question? And I think, going back, Pablo Picasso, right before he died, he was criticizing computers. And he said, they're overrated because they only give us answers. They don't tell us what questions to ask. And I think the more you bring in people from the outside who are not within our vernacular and are not within using the same vocabulary, you can reframe the question. It's exactly what happened with the L train, right? The question was reframed. And if you reframe that question, and if you're stuck in a problem, and then you take the time to reframe it, you can get an answer that is more on point, as long as you take the time to frame it properly.
So this gets us back to this vitality circle, because when you talk about it, everyone here are doing things in their business and academia that requires you to balance two things, right? Whether it's running your architectural practice or construction practice or operating buildings efficiently and cost effectively, or making sure that the basic education you're giving your students is the highest level possible. At the same time, you're trying to balance with like pushing the envelope forward and making changes. This is the big quandary. How do you balance that? How are you making those choices? Because I'll tell you, there's a bunch of folks from Thornton Tomesseti. I spend a lot of my time, maybe 70% in that right circle, and there's a conversation about, well, whoa, wait a minute, come on, we've got to run the day-to-day business. And yes, of course we do. We have to balance those two. But at the same time, it can become very addictive, right? Because what you're doing is you're changing the industry, you're making really, really exciting steps. But as Ray pointed out, whether you're Kodak or you're Blockbuster Video, you can wake up on the wrong side of history if you don't balance it. So how do you balance it? Let's start off in academia. How do you balance making sure that you're given a world-class education? Because if you lose that at Columbia, it doesn't really matter if you're solving an L-train problem, right?
No, it's a great question. And I look at this as also, if you follow or have heard Clay Christensen speak about disruption, is that to really add a new flavor, you add it in parallel while the regular train keeps on running. So, for example, if you think of, if I think in education. We're committed to providing a foundation for the future for our students. So our students come for an education that's really going to last a lifetime. Of course, we also now know we need continuous lifelong learning as a very important part of education going forward. But the first critical part is the foundation. And the foundation does need to evolve. So I'll give you an example. We now are looking very carefully at how do we introduce data science as a foundational element in undergraduate engineering and applied science education. So we've made shifts in our calculus offerings, because you can't just dump more on top of a student. There's only so many hours in the day, although we all like to stuff a little bit more into education each time. But we've offered a data science foundations course in parallel. Departments are now shifting to also include that in their majors, right? And we saw instant shift in the mechanical engineering Master of Science saying we're going to have a data science foundations as part of the Master of Science in Mechanical Engineering. So the sense of that you've got that even the foundation needs to shift, and it needs to shift in parallel with adapting the older curriculum to the new, to make sure that we're offering a foundation for a lifetime. And then on top of that is really understanding how do we really serve our current students and as they become alumni and others out in industry, out in the real world, because today things are changing so rapidly, right? The knowledge that you need is changing so rapidly. So we're adapting by offering courses online, offering ways to have more lifelong learning in more modular ways in executive education or that can be offered online and on campus. This sense that people need to be much more adaptive in the future And the future is now for that, as we all know. So the sense is that we have to really be even rethinking education, both the traditional 4 years and what goes on after the 4 years. So this is absolutely something critical in the academic world, and you might not in the AEC world be realizing how critical this ambidexterity is.
Well,
in
you
the
talk about the
academic
rapid
world.
change of knowledge you need. I always say when I came out of school, I think my education was good for a good 10 to 15 years, right?
Yes.
And we talk about our young staff coming out, they're lucky if it's 3 to 5, right, before they have to actually kind of freshen up their knowledge. But getting back, Chris, let me ask you, running a business is a practice, again, same, how do you balance it, right? You have to be that world-class architect that's coming up with these visionary designs. At the same time, you're trying to change the process and technology, and I'm sure you have the change challenges with your partners. Okay, where's the balance? How do you draw that line?
It's a huge challenge. I mean, you know, the thing that we're constantly reminding ourselves of is that we're service providers. So you got to sort of step out of that mentality. Now, of course, you got to, in order to push R&D, you got to have money coming in. You got to, you know, meeting those deadlines, getting the repeat business. So that's obviously very much, and so one would argue, you know, in terms of, you know, venture capital and the way it works in the world where people are pitching ideas and they're getting support, you know, for us, the blessing in disguise is that we have real problems to deal with, and we could really hone our focus in on them. So I sort of see it in sort of 3 different sort of levels. There's the evolutionary level, where you're like, look, there's certain technologies that evolve, and you're going to evolve them based on your process and how you think it'll make you a better performer. And you get repeat business, and you develop your brand around them. And I think in terms of the modeling process and direct fabrication, those and simulation analysis, and visualization, I mean, when you talk about augmented reality and virtual reality, it is becoming such a great way not only to visualize data, but get decisions very early on. When you can get decisions early on, you are cutting, you know, you're performing better. The money's coming in much quicker, and you're able to take in more work. That's one area. The next is you come up, you see a problem, and you're like, hey, we could design a company around solving this problem. So I think the first time we did that was with Envelope. You go out there to all these different client developers, and everybody's like, could you look at the zoning? It costs about $20,000 to $25,000 to do a decent zoning analysis. Imagine if you could do, if you just got the base information, you were able to generate a zoning model with a spreadsheet in 60 seconds. Yep. And then you were able to apply that to multiple sites and actually start to say, hey, this is the one we should really focus on, and then let's do the real analysis with that one. So you could, instead of maybe doing 3 or 4, you're actually doing, 50. And so we incubated that idea in the office for about 18 months, and then we found a CEO and staff to go take that and start a company with that, and that's moving very nicely. And then the next crisis that came up was this whole, the fact is, working in New York City, the cost of construction is just, let's just say it's 3% annually. We know it gets higher, it could be 7%. So it's not going down. And then you see the mayor says we need 260,000 units of housing, by 2025. There's no way we are going to meet that demand with the way that we build. So there's a lot of focus on prefab and modular construction. And the amount of money venture capital is putting, it's just Qatar alone, So the thing is, for us, is now we can take some of the IP that we developed with our modeling processes and start bringing in people from outside. I mean, talking to people at Tesla, people at SpaceX, people from Citizen M, and starting to understand how you leverage those other models. And so we're in the process of creating another company. But it's not a construction company. It's a software company. And so the thing that we did different between Envelope and this new company is we gave ourselves 9 months and $500,000 to incubate the idea. And then we shared that idea with venture fund, who are our partners, and they have all the connection to the venture capitalists. And so they started coming in, and they were coming in from different worlds: real estate, the tech world, construction, and everybody could see that, you know, this model is a bit different from some of the ones that are out there. But the thing is you're mixing it in with all these different skill sets. And the whole idea is now you got to send that out there, and you got to get people in to help run it. And so that's one of the challenges. The third way, which is sort of something you should talk about, Tom, is this idea of creating a consortium. Where you have people from the engineering world, the architecture world, from the construction world, pool their resources and money, and you pick ideas. You sort of interview ideas, and you pick a few of them, and everybody starts piling on and seeing, you know, giving it a certain time, going through the gate process to see, you know, how it's going. So for us, there's many, I do see several different layers, different ways of approaching this. But at the end of the day, you know, I think it's really important that we get out of this service provider mentality and become authors again, sort of directors of where innovation should be going, and really take that mantle.
So, you know, I brought up this slide of all the VCs that are looking at our, not all of them, but a big selection of ones that are looking at our world. And an interesting thing, as you mentioned, you know, we've gotten into this by spinning out a couple of companies, and we've started to travel in these circles. But it's that balance that's really interesting for our industry to find, because, you know, there's a lot of VC folks that are out there trying to solve our problems without a lot of our input. Yeah. And if we let them, eventually they will. I use the example of, you know, the monkeys banging on a keyboard, eventually Shakespeare comes out, right? If you leave enough time, right? But what we have, as somebody articulated to us once, is the unfair advantage. As you said before, we actually have a project or a job or something to try that out on, right? So if we're engaged in that conversation, it's a much better chance of getting to that solution faster. So how do we balance it? Because we certainly would like their money, right? Because yes, Thornton Tomesseti is invested in things, but there's only so much in our consulting business that we can handle. Unless the Rudins of the world decide to double our fees, then we're all good. But how do we balance this? How do we balance the self-funding and then bringing in the outsiders to again, you're not an outsider. Academia should never be an outsider. We're the insiders. The outsiders are the people with the money. Yep. And how do we balance that? And how, you know, you've started to do that. We've started to do that. How do you see that happening?
You know, from our standpoint, the last people you should be talking to are venture capitalists. If there's any of you in the room, you know,
we'll get that question from them later. So.
I think that comes last. You have to come up with a product, and products are derived from domain expertise. And unless you have that domain expertise, unless you have a lab like Suffolk has at the top of their building, which is an amazing, you know, you would never think you're in the office of a construction company, and yet they're able to visualize and create that digital twin. You're going to hear a lot about digital twins. You know, from an owner's standpoint, if you're creating a digital model of the building that you're going to build for us or on behalf of us, I want that model. Mm-hmm. I want that model because I'm going to overlay my operational pieces on top of that. Don't waste that. Use that. You know, that's, to me, the beauty of the digital world is that nothing gets wasted. You can use it from, you know, cradle to grave. And if you're smart enough to do that, there's a great company that we invested in, Triax, and what they do is they create wireless networks as you're building the building so that you're able to monitor. You know, it drives me crazy. Oh, how many electricians do I have on the job today? Oh, we've got 26. Really? Really? You know, I know there's 14 guys and gals out there. There ain't 26 electricians because I can see what the productivity is. So let me know what the real data is. Let me know where my equipment is. Let me identify from a safety standpoint that someone is picking up heavy steel the wrong way so that I can go then train them to do it properly, in real time. So from our standpoint, it's really, the balance is organic, right? So I use the term organically grown, from internal data, and how do you mix that with your external forces? Because you're going to need those external forces. But at the end of the day, from a venture capital standpoint, the later you go to the VCs, the better, because the more mature your product is, what we're focused on is really strategic investors, people who ultimately understand what we're doing and want our product, because we've already built the company. So, there's an evolution here that you've got to be careful of, and understand that you can do these things yourselves for longer and for more miles than you think you can, and it's not easy. This is not for the faint of heart to start companies and to spend money that maybe that'll evolve into something and maybe it won't. But if you can, the longer you hold out, the better.
Yeah. So I actually agree with everything John says, but just for fun, I'm going to play devil's advocate, right? I think the benefit of capital is that it can just do things faster. Right. And at the end of the day, you're not, success in the world isn't judged by what the return on money is. And if you have enough capital, you don't worry if some of it's wasted, right? And I think to some extent, like if you read what, I think Matsuhisa's son is his name, the SoftBank, SoftBank gentleman, his deal is that I'm going to give you more capital than you think you need right now. And, because that's going to make you go faster. In today's world, scale is everything. A lot of this networked things that are platform plays, the first to post is winner takes all, right? And so the second one doesn't necessarily get anything because there's a lot of barriers to entry. Data is the same thing. If you hold all the data, even if somebody else comes later and builds a similar product, barriers to entry are high. And so I do think a balanced approach is necessary. I think we do have the strategic advantage that we have domain expertise and therefore know what problems we need to solve. I think we are hobbled as an industry, though, by the fact that sometimes we don't know the art of the possible. What is possible, right? So unless you have someone that's actually really good at software, and software talent is pretty expensive nowadays, that can see the art of the possible. Somebody else that can have $1 billion war chest that can go hire the best of the best, they're going to figure it out. They're going to figure it out before us. So the approach here should be to participate. It shouldn't be to not participate, is my personal belief. It may be to pool money, because the industry is quite fragmented. R&D funding, all the facts show that we're one of the lowest, one of the industries with the lowest percentage invested in R&D. Yep. So some of those VCs there is a pooling of funds into a venture fund, right?
To that point, Chris and I have been talking, some other people in our industry talking. So when we spun out this company on scale, and so there was the Series A people, actually pre-Series A people coming around, yeah. And there'd be these people in Silicon Valley, the so-and-so angels and this and that, and they'd get in at a nice valuation for a relatively modest, and we're like, why are they getting in? They said, well, because people in the industry know them, and if they get in, then it's good for you, that'll lead on to higher funding. And we've been talking about, guess what? We know our industry. Why don't we pool our resources? Why don't we become the AEC angels? And why don't we be the ones that are actually throwing the dollars around? Because we are the ones who can actually make the best bets, rather than let somebody on the outside come in and make those bets. And I think part of the answer to that is because if we were good at collaborating, we probably wouldn't be here in the first place. But, but I would love to see that change, where actually there is none of this. Yes, we may be able to pool at different rates depending on what our business models are. But how do we get together and do that. And I know some, in some areas of academia, they've been, reaching into the professors of the world, letting them still be professors, but then letting them take that information and have somebody else develop it so that they can still be who they are.
I was going to build on what was said here, is that when you have a VC come in, it's not really, we have this external VC come in. It's often a domain expert has left a company, which you sort of have a little bit of that model, you spin off. And the VC is not only providing funding, but is also bringing in other perspectives and saying, you might need to bring this other technology that we saw over here into really catapult this. So there's another mixture of ideas that come in. Because new companies morph as they develop. They don't just stay with what the initial idea of it. And so, yes, it's important to have the domain expertise, but you're trying to bring in other viewpoints. And I think it's VCs, the big successful VCs are not just giving money.
Yes.
They're also bringing in other perspectives, and they're helping guide that company in a very different way. So it's not just about, okay, well, we have the money ourselves, we can just do that. I think there's some other dimension that's being brought to the table.
And that's really important, because that we've experienced that. I agree with you wholeheartedly. Getting, we just raised $6 million in a very short period of time. I tell you, we're already realized we're going to be running out of that. But it's when the VC come in and say, oh, you've got to talk to these people. Right. And then, you start talking to people at Boeing or at Tesla, and suddenly the connections are happening much quicker, much quicker.
So full disclosure, Thornton Tomesseti has a lot of good VC partner friends now. So we both on ones that are investing in our products and ones that we're actually investing in their funds because they like us to be there to look into the world that they're looking into. Why isn't it happening? Why did it take people on the outside to make that happen? Versus, it's nice to see the change finally happening, but it's a shame that it took this long for it to happen.
Because they probably all have hired architects and go, oh my God, the project's over budget and it's behind schedule. What is going on here? I'm going to do this. I'll figure it out.
So, and it's also it's the time really, I think, of immense opportunity in the whole world of infrastructure. That there's such a dramatic need across every part, whether it's buildings or roads. Everywhere we look, we need innovation and we need infrastructure, whether it's rehabilitating infrastructure or new infrastructure. There's so much need in this country right now, let alone around the world. And so why are VCs or others interested is because they see there's an opportunity to really do things faster, quicker, better, and there's a lot of money behind it.
To the chart we pointed, to the chart we put up earlier for Chris with that big gap between in productivity. Yeah. You monetize the reduction in that gap. There's a lot of money there. Right. So
my only point is that don't give away your company.
Right.
That's
good advice.
That's where the brand of your company helps out a lot.
That's right.
Yes.
Really.
Yeah.
All right. So I think Jim can tell me we're getting close to yes, because I think we're at the point where we really need to open it up to because as you could tell from all of us, we could probably keep going on for another hour or two. So what I'd like to do is I think we have some mics on somewhere over here. Yes, somebody's walking with a mic. No. Yes.
on the stands right there.
Or will be soon. So any questions from the audience? And please, obviously, tell us who you'd like to start, at least the answer to that question. Because we could keep going, because I've still got a couple more to go. But so, any questions from the audience?
I'd like to ask.
Okay.
I'd like to pick up on what John just said. Don't give away the company. I'd like to know why our industry fees are going down and we are working for less and less, as opposed to materializing our expertise into a more significant income. Did you hear me?
So the question is, why why in our industry are we giving away our intellectual property, and I would put it in that way, versus monetizing it ourselves?
Well, let's start with the facts, right? The real estate industry is the largest asset class in the world. This number 2 is not even close. We don't realize that, right? We're all, real estate is very local in many cases. We have our building, we have our house, we have, it's ours, right? I think our industry also suffers a little bit from a little bit of an inferiority complex. As Chris talked about, the Teslas of the world and the others that are pushing technologies. And yet, once we really look at ourselves in the mirror and we realize that who else could solve our problems better than us, it just, everything changes. And you really begin, at least in our experience, you really begin to look at your buildings differently and understand that as what's happening in the real estate industry right now in New York and nationally and even globally is property owners coming together in smaller groups and identifying problems that need to be solved, and then identifying the companies that are actually solving those problems, and then investing in those companies to make them winners. And we're doing that on multiple levels with multiple friendly and unfriendly competitors. And because we see, we talk about data, right? If someone's going to come into a Rudin property and take data out of our buildings and take the data out the back door and monetize it, shame on me. Yep. Why would I ever allow that to happen? And yet, when you really take a look at many of these companies who are knocking on all of our doors and wanting to come into our buildings, that's exactly their business plan. Yep. So that's why we created Nantum in the way we did as an operating system, because, and we're working with a lot of owners to create a data bill of rights. These are the 5 things that you need to do and have as part of your product if you think we're even going to entertain you coming into our buildings. Because what I don't want to have happen is to die a death of 10 dashboards. That's why we created Nantum as a single integrated platform that everything can then plug into. And data can be expressed properly, whether it's from a design standpoint, we can measure and verify in terms of certain design aspects based upon what energy is consumed within that space.
But I would argue that our industry, and maybe not real estate developers, but our industry, architects, contractors, academia, are maybe too humble. And the evidence I will give of that is we were in a meeting with a VC just this week who accused me of being humble, which was very humorous from the people who were sitting in that meeting with me, Gary and others, saying that none of my partners have ever accused me of being humble. But they were talking to us about opportunities, and I was pointing out the things that we couldn't bring to the table versus what we could bring to the table. And I feel like that's one of the things that we have in our industry. I even think that's one of the things we have in academia, where we're always questioning what we don't have. And what this VC said is, all the people who are monetizing your brain, they don't know half of what you know, but that never stops them. Yeah. Right? So how do we change the mindset in our industry?
Compared to some of the conversations I've had with some West Coast kind of like startup CEOs, it's totally true. Right. Relative to those guys, we are completely humble. The word I like to use is that we're real. This is a very real industry in a way that I think many other industries have not been. Maybe it's because we build very tangible products, right? Like you see that building goes up, it sort of sticks around for 50 years or more. And so we're just we're a very pragmatic industry. Mm-hmm. And maybe that hurts us in the capital raising stakes, right? Maybe we don't dream those visions of going to the moon.
Well, the other part too to that is, venture capital, we're used to seeing returns within 18 months.
Yes.
Now, when you're dealing with software and you have a bunch of engineers in the back room just doing code, it's like that, that Facebook scene in the suburban house in California, The fact is, on average, it takes 5 years from start to finish to do a building, a 30-story building. and all the things that go into that process. And I think a lot of the VC are starting to realize this is a long game operation, and that's a good thing. But it is still a challenge, and I got to tell you, this whole thing about lowering the fees, well, if there's certain things that are just easy to do, everybody's going to do it, and the one with the lowest fees is going to get it. So that's why you got to keep innovating. You got to keep providing value, simulated data. There's a lot of what is being talked about. That is incredible value. You bring people into a VR cave, and you can do tenant fit-outs and pre-design and get sign-off on that. Then, when I remember Rem Koolhaas, when we were in school, he gave a lecture, and he asked, how many out of 10 projects, how many do you think we actually executed on? Everybody's like thinking, oh, maybe 7 or 8 because he's famous. No, 1 out of 10. So imagine all the value, all the brain power that went into 10 projects, and you only realize 1 of them. Yeah. I mean, it's sort of like baseball. That's a crappy batting average. So the thing is, that's where, looking at these other sectors, bringing in this other intelligence, then you can start charging higher numbers because you're managing your clients' risks. The other thing to add is finding the clients and the engineers and the builders who are really interested in this, like Lend-Lease. Lend-Lease is so interested in prefab systems. There's companies in Europe that are very interested in, again, understanding post-occupancy management models, like you're talking about, John. Finding those kind of people, they don't throw the digital model away. They want the architects and the engineers to develop that digital model so it becomes part of post-occupancy. That's huge value.
Huge.
So I would just say that I wouldn't think that I wouldn't want you to think that because it's a long game, people aren't going to come in with something very much more innovative and disruptive. It might cost a lot more, but there's a lot of money involved in this industry. Yes. And so just take a look at space, okay? SpaceX has come in extremely disruptive, right? Virgin Galactic, et cetera, whatever, that we're now having, commercial possibilities and much faster development than NASA ever could do it. Okay, so, and now NASA is contracting the commercial companies. Lockheed Martin shifted gears because they had to do things differently if they wanted to still be competing in that industry. And this is a long game, okay? It's not going to happen tomorrow. So it's not a bunch of software, engineers sitting in an old house somewhere. This is a long, detailed technical game.
Yeah, I call it for any Star Trek fans out there, it's a Vulcan mind meld. Right? I gave that line, and someone stood up in the back and did this. And it's really a Vulcan mind meld in our case with our operating engineers, many of which didn't go to college, but they can take apart a chiller and put it back together and fix anything with some really smart data scientists, computer programmers, and yet what do they know about running buildings? Mm-hmm. Well, every day they learn a little bit more, but they're basically sucking the brains of these folks at Rudin, collectively hundreds of years of experience in terms of how do we squeeze as much comfort as we can out of these chillers regardless of how old they are. And how do we ultimately then use data sets that never talked to each other before, occupancy with fan speed, to drive the cost and the consumption down? We've cut our carbon by 44%. We've cut our electricity by 41%. We've cut our steam by 48%, simply by allowing that Vulcan mind meld to happen. And to the question in the back, the one thing that's not on your chart, Tom, is curiosity, right? You need, people say, what do you look at in terms of hiring people? I care if they're curious. Mm-hmm. I care if they're insatiably curious. They're constantly find that answer, find that answer, find that answer, and then think up new stuff while I'm sleeping, and knowing that they're smarter than I am, and not being afraid to surround myself with some really, really smart people who I know are smarter than me.
So just one point to the long game and this idea so we are in a long game industry, but what's interesting is if we get together as a group, in a larger and larger group, something we find at some point in the game on a project you're working on can be implemented instantaneously in some other project somewhere else if we're talking to each other,
Correct.
right? So larger firms, you have a little bit of that inside, but as we're talking to each other, we don't have to wait. So we've spun out this tune mass damper for tall buildings.
Right.
Well, we may not have, Thornton Tomesseti may not have the right opportunity for that tune mass damper right now, but somebody does. Right. And so as an industry, if we're talking, if we're getting this information out there, we can speed up the cycle, but that's our collaborative challenge, right? That where we have to get more people out there talking about this so they hear about the solutions, and you're not waiting for the job to implement it on. Right.
And Tom, I think you're going to start seeing more of these. I mean, we are very used to collaborating on a project, obviously, right? This is where a lot of different stakeholders come together. I think, speaking just from the data side, and it's linked to the question the lady asked in the back around, are we capturing the value? And I would say we are. Maybe not in fees, but in returns from some of these companies, right? Returns in the outcomes. The second chapter to that story I told around the predictive safety proof of concept is that it's sufficiently intriguing that now other companies say they want to play. Other companies like us, contractors, right? The deal is, we form, anchored by that startup that did the work, you form an alliance. People contribute data, but then they are offered a stake if they want to in the company, so that you're not giving things away for free. Because I completely agree with you. You shouldn't, data is valuable. Safety was an easy area to actually start that collaboration. We can all agree on the outcome, and there's no, everybody's interested in floating the industry, right? The competitive concerns are a little bit less critical there. And so we're going to talk about it in a month at ENR, but this group of 10 contractors, and each time we talk about it, more people are like, hey, that sounds interesting,
I'll put my pitch in for the Building Congress Council on Innovation because we brought that together really to try to get because it's a group that covers everyone from owners to labor to architects, engineers, academia. And the idea is if you can get everybody, we have an event coming up in June, you get them all in the same room, we get to talk, those kinds of things can actually translate quicker into a solution versus how long it'll take if we all try to do it in our own silos. So I don't know if we have time for one more. Is there another question out there? I think we're going to have to wrap up soon. I know that we all have deadlines, but actually, not the Thornton Tomesseti stockholders. We're just heading for drinks and dinner, so we're not leaving this location.
Mary's got to go teach a class.
Yeah, I know, yes. So any other questions before we, yes? Well, yell it out and I'll translate if we can't hear. So.
Okay, my question is mostly for Chris. I was wondering what role you see for vertical integration in the industry, kind of like Katera is trying to do, if that's something that is scalable or not.
Well, it's interesting because I was at Katera in February, and it's interesting with SoftBank how much money they put into that company. And Katera's buying up a lot of other companies. So a lot of that capital is going into overhead and acquisitions. And, to me, it's almost like it's just replicating something that already exists. Okay, so I'm going to buy a lot of construction companies and supply chain. I'm going to buy my supply chain. And I'm not sure that that's probably the most optimum way to think about that. So thinking about, the whole process, which we're constantly engaged in, I think is something that is critical and can be modeled. And you can get real data from that. Yeah. And it's caused us to think a bit differently about, where the focus should be. And you'll probably hear more in the coming months about that. But I'm noticing this with a lot of companies that are going into prefab and modular, is that they're basically just buying a lot of infrastructure. They're spending a lot of money on infrastructure and not necessarily focusing on the process as much. Not to say that they aren't doing it, they are. But if you go into Katera, there's still in wood and PVC pipe. I mean, the innovation, yeah, there's going to be some automation, but we saw at Tesla that actually over-automation was a problem for Elon. There was things that were just easier to have people do it. So yes, we're understanding that process, especially the supply chain. Boeing's a good example. The Dreamliner model is a really great example for our industry to sort of look at. You know, looking at how you look for strategic partners. See, in our world, we have to deal with this competitive bid. Our culture is always like, we want competitive bid and go for the lowest price. But imagine if we could pre-qualify all our subs and say, we've got the dream team for your project, and we're going to give you a guaranteed maximum price. But you're going to get it on time and a good quality project. But we're not allowed to do that. We don't operate unless you find a good client.
We clearly have to stop the conversation because you're drifting into fantasy land.
Yeah.
So. All right.
Sorry.
With that, I'm sorry. I know we've got classes to teach. So Mary, thank you, or whatever your deadline is. John, Jitki, Chris, thank you so much. We could continue this conversation forever. So pleasure meeting you.
Really nice to meet you.
Need to work together sometime.
I'd like to invite you all for cocktails and some appetizers. Hopefully, we know that other people may be at eTruly at this moment because they went to the wrong location. Just so you know, we are having a 70th anniversary party, so there's no party tonight, just some drinks. We will be meeting, hopefully, we all get invitations in September to our anniversary party. But please join us in the lobby for some drinks and appetizers and some more conversation. Thank you.
Thank you.
This was great. Great conversation. Thank you so much. It's so great to see you twice. We'll have to figure out more reasons to cut to.